So 3.4 concavity and the second derivative test. But before I do the second derivative, I want to talk about the first derivative. When we take a derivative set equals 0, what do we find? We take critical numbers. All right? And those critical numbers can be relative mins and maxes and such. But what makes a relative max? F prime changes from positive to negative. What makes a relative min? Good. All right. So those are happening at those critical numbers. Now, we're going to talk about slopes again. Well, what's kind of my slope here? A pretty big negative, right? And a lesser negative, then a lesser negative, and a lesser negative, and a lesser negative, and then 0, and then what?
Positive.
A positive, and then a bigger positive, bigger positive, bigger positive. Now, what's happening to our slopes?
The slopes are increasing.
The slopes are increasing. And if I talk about just a function, and if I say it's increasing, then I'm actually talking about the slope of the function. If I talk about the slopes of the function increasing, I'm talking about the second derivative. And that means my second derivative is greater than 0, which means this word called concave up. All right? My slopes are increasing. The slope of the slopes are positive. Now, let's talk about concave down. Well, what's happening with these slopes? This is a big positive and a lesser positive and a lesser positive and a lesser positive and then 0 and then a negative and then a more negative and a more negative. What's happening to my slopes? They're decreasing. So the slopes are decreasing, which means I'm actually talking about the second derivative. I'm talking about the second derivative would be less than 0, and that's called concave down. All right? Pretty good? All right, bust out your hand. Here we go. Bust it out. Bust it out. We talked about this before a little bit, but now we're going to talk about the second derivative. This is concave up. Do you see how it holds water?
Yeah.
Okay? If you flip it over, that's concave down. You see how it spills water. All right? So that's kind of the slopes of the slopes. All right? Pretty good? All right. All right, so now we're going to talk about the open intervals of this function being concave up or concave down. Well, if I'm talking about concavity being up or down, what do I need to get to? The second derivative. But before we get to the second, we have to get to our first. Now, which way you want to go? Doesn't matter to me.
Power -1.
All right, you want to do power -1? All right, so I'm going to manipulate that to say 6 times x squared plus 3 to the negative first. Now I'm going to take a derivative. So what gets brought down? -1 plays with 6 to be -6, and then I have x squared plus 3 to the negative second, but what pops out? 2x. All right, so if I were to simplify this, I'd end up with negative 12x over x squared plus 3 squared. Now, if you want to, we can say that's the power of a -2 and do a product rule, factor out at least power, or do you want to use quotient? Doesn't matter to me. You want to use product quotient. Who wants what? Quotient? Let's do quotient. Or quotient it is. All right, so now I'm going to find f double prime. So the derivative of the top is -12 times x squared plus 3 squared minus the derivative of the bottom. So what's the derivative of the bottom? 2 times x squared plus 3 to the first, but what pops out? 2x. And then times the first of, or the top of, -12x. All over x squared plus 3 to the fourth. Now, what I notice is that this has a squared, this has a 1, and this has a 4. So I want to get rid of one of them. All right? So I would now make that a power of 1. I'd just get rid of that. And then instead of a 4, I'd make that a 3. So now we need to simplify it up a little bit. So -12, I distribute, so now I'm left with negative 12x squared, and then minus 36. A negative 2, a 2x, and a negative 12x become what? Negative 48. Oh, just positive. I'm sorry. Positive 48x squared. And I still have x squared plus 3 to the power of 3. And then we can simplify that up a little bit. So how many x squareds do I have? 36x squareds minus 36 over x squared plus 3 cubed. Now, because I'm going to set that equal to 0, I would kind of factor it a little bit more. What could I factor out? 36. And then I'd be left with what? X squared minus 1. Well, what does that factor to?
X minus 1, x plus 1.
Good. And so now I'm going to set that equal to 0. So what do I get? X equals negative 1 and x equals 1. Now, when I take a first derivative and set it equal to 0, what do we call those things? We call those critical numbers. I'm going to get to it on the next page. These also have a special name. These are also called possible points of inflection. All right, I like to call them p-poise. Okay, we'll get to it on the next slide, but it's a possible point of inflection. All right? So just like the other ones have the name critical numbers, these are called p-poise, or possible points of inflection. All right, so let's make our intervals. So now I have negative infinity to negative 1, and then negative 1 to 1, and 1 to infinity. So now I'm talking about the second derivative. So let's pick something on that interval like negative 2. Sounds great. So if I substitute a negative 2, this would be a negative, this would be a negative, so I end up with a positive. So f double prime is greater than 0, which means concave up. All right. And then negative 1 to 1, let's pick something on that interval, like 0. So this would be positive, this would be negative, so what do I know? F double prime is less than 0, which means concave down. All right, let's do 1 to infinity. So let's pick 2 or something. So then I'd get what? F double prime is greater than 0, which means concave up. So let's make sure we answer our question. We are concave up on negative infinity to negative 1, and when else? 1 to infinity. And I'm concave down on the interval negative 1 to 1. All right, pretty good? All right. So a point of inflection is when f double prime is equal to 0 or f double prime does not exist. Now, I don't actually think they are points of inflection. They are possible points of inflection. I actually disagree with Larson on this part. These are possible points of inflection. To be a point of inflection, it must change concavity. Okay? To be a point of inflection, it must change concavity. Just like a relative min or max, f prime changes from positive to negative, or f prime changes from negative to positive. It has to change. So a point of inflection, it has to change f double prime being positive or negative. Okay? Or negative to positive. All right, here we go. So we're going to find the points of inflection and talk about the concavity of this graph. So we have x to the fourth minus 4x cubed. Well, if I need to talk about points of inflection or concavity, what do I need to get to?
Double derivative.
Second derivative. All right. A double derivative. I like that. I had a young lady, Alyssa Gillen. She would call them prime primes. She'd say f prime prime. I kind of liked
Yeah,
it.
you can't do it 3 times. Or else it's prime
I mean, you could.
Prime.
All right.
This one is good as-
So what's f prime? 4x cubed minus 12x squared. I mean, she went to UF, got a 5 on the AP exam. She wants to call them prime primes, call them prime primes. Tag on it. All right. All right. So I need to get to prime prime. So f double prime, we get to what? 12x squared minus 24x. Now, eventually, we're going to take that and set it equals 0. But I'd like to factor something out first. What could we factor out? 12x. And so then we're left with x minus 2. I'm going to set that equal to 0. And so I get x is equal to 0 and x is equal to 2. Those are my p-poise, my possible points of inflection. All right? Okay? All right, so let's make our little chart. So now I have negative infinity to 0 and negative or 0 to 2 and then 2 to infinity. All right, let's pick something on that first interval, like -1. So what would I get? This would be a negative, this would be a negative, so then I get positive. So f double prime is greater than 0. So that's concave up. And then let's choose something on 0 to 2, like 1. So that would be positive, this would be negative, which makes f double prime less than 0. So that's concave down. And then 2 to infinity, that would be concave up. So f double prime is greater than 0. So that's concave up. Now, what's happening at x equals 0? I do have a point of inflection at 0. All right, because our concavity is changing from positive to negative, but so it changes. Now, to be a point at x equals 0, I'm going to have a point of inflection. But to be a point, what also do you need? A y value. So we need to substitute back in the original. So if I substitute it back in, what do I get? 0 as well. All right. And then at 2, do I have a point of inflection? Yes, because our concavity changed from negative to positive, or down to up. All right, so if I substitute back in 2 to the power 4 is 16 minus 32. So I end up with -16. What just happened? All right. So I have a point of inflection at 2 comma -16. Now, I really do want to show you this graph. So I have an x to the 4th graph, but do you see what's happening over here? You see what's happening right there?
Yeah.
It's concave what? Up. So it's this portion of my hand, that portion of it. You see how that works? Then it's concave what? Down. So it's actually that portion of my hand. You see that? Then it's concave up. So now it's that portion. See how that worked? All right. So that's kind of how you kind of use your hand on these. Good? All right. Let's do another one. So now we're going to use the second derivative test to find relative extrema. Well, how do we find relative extrema? We've already done this. How do we find relative extrema? Take a first derivative and do what? Set it equals 0. And you find what? Our critical numbers, right? And then I make my little sign chart and we figure out where f prime goes from negative to positive and positive to negative, right? That is one method. I'm going to take you to another method as well. All right? But we're going to start out the same. So, relative extremas definitely happen at critical numbers. So let's take a derivative. What's f prime?
-15.
-15x to the 4th plus
15x squared.
15x squared. I'm going to factor out something before I set it equals 0, like a -15x squared. And then what would I be left with? X squared minus 1, right? So when I set that equal to 0, I get x is equal to 0, and x is equal to -1, and x is equal to 1. All right? So those right there are my critical numbers, right? And that's where a relative min or a max might occur. So I could make my intervals and see where they change, negative, positive, positive, negative, right? I don't want to do it that way. I want to show you another way to Tampa. And sometimes they make you go this way to Tampa. I'm going to get to a second derivative. All right? So let's take a second derivative. So what is f double prime? Negative 60x cubed and then plus 30x. And I want to factor it out a little bit to help me out. So I could factor out a negative 30x, and then I'm left with x squared, or 2x squared, I'm sorry, minus 1. Now, I don't need to set that equal to 0 because does it ask about points of inflection? No. We're talking about a relative extrema. So I'm going to find what f double prime is at -1 and 0 and 1. Because a critical number is where my derivative is 0 or doesn't exist, right? So it's a relative maximum or a relative minimum. Let's look at our hands. If I have concave up, where is my critical number? It's a relative what? Minimum. If I'm concave down, I have a relative maximum. That's how we use the second derivative. So let's substitute in -1 into our second derivative. And all I care about is the sign. So if I substitute in -1, this part would be what? Positive. This part would be positive. So f double prime -1 is greater than 0. Which means I have a what? Concave up, which means what? I have a relative minimum at -1. If we back substitute, that would end up being -2. All right. So I have a relative minimum because I'm concave up there. All right. Let's look at 0. So now I want to find f double prime at 0. Well, what is f double prime at 0? Aaliyah? It's 0. So do I have concavity? No. So is it a relative extrema? Not at all. All right. Let's look at 1. So what's f double prime at 1? Positive or negative? It's negative. It's less than 0, which means what? I'm concave down there. All right. Which means if I'm concave down and it's a critical number, what do we have? A relative max. All right. So I have a relative max at 1 comma something. If I back substitute it, what do I get? I get 2. All right. So here's our graph of this function. Now, if f double prime of 0 is equal to 0, that means it's a what? A possible point of inflection. Okay? But let's look at -1. Do you see how I went from concave up and it was a relative min? See that? And then this one's a relative max because it's concave down at that critical number. All right? This is actually what at 0, 0? Yeah, it's horizontal, but what is it at 0, 0? It's a point of inflection. Now, did I prove it analytically? I did not. But at 0, 0, it changes from concave down to concave up. Do you see how that part looks concave down and that part looks concave up? All right. So at 0, 0, it's actually a point of inflection. All right. So when we're talking about derivatives of derivatives, that means concavity. All right. The slopes of the slopes is concavity. All right. Now, this is just a cool little chart. If f prime is greater than 0, that's talking about the first derivative. That means f is increasing. F double prime is greater than 0. That means it's concave up. So all of those things can happen at different things. All right. All right, I'd like you to write down your homework, and then I want to talk about a couple other little things. All right. So the first thing that I want to talk about is if f of 3 equals 5 and f prime of 3 equals 0 and f double prime of 3 is equal to negative 2. What do I have going on there?
Concave down.
It is concave down, true. So that's f double prime is negative 2. That means it's concave down. What else?
Point of inflection.
I don't have a point of inflection.
A horizontal tangent line.
I have a horizontal tangent line, which means it's a what?
Critical.
I have a relative extrema. What kind of relative do I have?
Maximum.
I have a relative maximum. Exactly. So this is actually a relative maximum where? At what?
3, 5.
At 3, 5. That's what these three things said. I have a relative maximum at 3, 5. Because f prime of 3 is equal to 0, that means it's a critical number, true? This part means it's concave what? Down. Raise your hand. Guess what I have? A relative what? Max. All right. So now I have this little curvy curve, right? If it were an F graph, if this were an F graph, where is my relative maximum? If that's an F graph.
B.
At B, right? Where would my relative minimum be?
D.
D, right? Now let's make it an F prime graph. Where do I have a relative maximum at?
Nowhere.
A relative maximum.
Nowhere.
I got one. It's at C. I have a relative maximum at C. Why?
Plus F prime is positive.
F prime changes from what?
Positive.
Positive to negative. Now, you guys could do that pretty well in your little sign charts. That's great. However, I need you to get it. Where do I have a relative minimum at? A and E. Why do I have a relative minimum at A and E? Don't say it.
F prime.
F prime changes from negative to positive. That's why I have a relative minimum there. All right? Where are my points of inflection if that's an F double prime graph?
B and D.
A, C, and E. Why are those points of inflection at A, C, and E?
Because they're changing.
Because F double prime is changing sign from negative to positive or positive to negative. All right? All right. Calculus isn't hard. It's just a what? Different way of thinking. All right. Good, good, good.